So let's go to probability distributions. Let's say we have a coin and we toss it twice. And let's say we get one heads and one tails. What would we think about this coin? Well, it could be a fair coin, right? It could also be slightly biased towards either heads or tails. We don't have enough data to be sure. So let's say that our verdict is that we think it's fair, but with not much confidence. So let's think of the probability P that this coin lands in heads. With a little bit of confidence, P is 1/2, but it could be a lot of other values. So the probability distribution for P is something like this graph, higher at 1/2, but a bit even in the entire interval, and very low on the corners 0 and 1. And now let's say we toss the coin 20 times and we get 10 heads, 10 tails. Now we have a bit more confidence that the coin is fair. So the distribution for the new value P is something more like this graph with a higher peak at 0.5. Now let's say we toss the coin 4 times and we get heads 3 times and tails 1. The probability distribution for P is now centered at 0.75 since we get 3 heads out of 4 tries, but also with not much confidence, so it's a graph like this. But if we toss it 400 times and it lands in heads 300, then we're much more confident that the value of P is close to 0.5. Therefore, the probability distribution for P is something like this, with a huge peak at 0.75 and almost flat everywhere else. This is called the beta distribution, and it works for any values of A and B. If we get heads A times and tails B times, the graph looks like this, with a peak at A over A plus B. The formula is this: gamma of A plus B divided by gamma of A times gamma of B times x to the A minus 1 times y to the B minus 1. If you haven't seen the gamma function, think of it as a continuous version of the factorial function. In this case, if A is an integer, then gamma of A is A minus 1 factorial. For example, gamma of 5 is 4 factorial, which is 24, and gamma of 6 is 5 factorial, which is 120. But the interesting thing about the gamma function is that it also takes values in between, so we can define things like gamma of 5.5, and it'll be something between 24 and 120. The actual formula for the gamma function is in the instructor's comments, although it's not something we'll use in this class. So what happens if we have values that are not integers, like say 0.1 for heads and 0.4 for tails? This makes no sense since we can't get 0.1 heads and 0.4 tails. But that's okay for the beta distribution. We just need to graph the right formula using the gamma function. And for values smaller than 1, like 0.1 and 0.4, we get this graph. That means P is much more likely to be either close to 0 or close to 1 than to be in the middle. This makes a bit of sense, right? If P is closer to 0 or to 1, then we're likely to have either 0 heads or 0 tails, which at least gets us close to one of the values, 0.1 or 0.4.